All right, guys, so let's get started. This is a live recording of 11.5, which is worksheet number 6. Okay, so we have 11.5 and then 11.6, and that's it. We have 4 sections for this upcoming test. Well, when you come back, okay? The Thursday you come back, you'll have the tests, and the Tuesday you come back. So hopefully some of your flights are coming in by Sunday, hopefully by Monday. So let's get started here, okay? So we talked about probability in the last section. We did some and, we did some pluses, things like that. And that was really one event. But I want to do 2 events, and that's the beginning of this worksheet, is probability of 2 events. So this is very important to grasp, because 2 events are happening, not just one. We will get into one event very soon here. Okay, so what is the probability of 2 or more events? So it looks like this. So we got event A and event B. What is the probability of those 2 happening? So basically you're going to do the probability of event A, and you're going to multiply it by the probability of events B. Okay? So this right here, stop it. Okay, there you go. So that means multiply. All right? And now we're going to assume, remember, we talked about this last time. If the first event happens, now we're thinking of the second event happening after the first event. Okay, so something like without replacement, that it affects the second event is affected by the first event. So that's just that you're going to see that here again, the whole with replacement, without replacement. So assume that event A has already occurred when you calculate B, okay? All right, so number 1. Now I don't know, I have this little 0 thing here. Do you guys have that? Right here? I don't know, that's not supposed to be there. So given a jar, so same type of scenario, with 5 red, 6 blue, 9 white marbles, what is the probability of pulling a red marble and then a blue marble? Now we don't have to do the whole tree diagram like we did in the last lesson, okay? All we have to do is first of all figure out what's the total. Okay, what is the total here?
20.
Yeah, so 20. So we know how many are in the jar. And we'll always put that number in the bottom, in the denominator. So what's the probability of a red marble and then pulling out a blue marble with replacement? So that means after we pull out the red marble, we're going to put it back. All right, so we're going to have the full 20 once again. So what's the probability of the first one? No, just how many red marbles are there? 5 total red, right? And 20 total. Now you don't have to write all this, but I'm just trying to show you where the numbers are coming from. Okay? That's probability of the first event, okay? The second grab is a blue marble, but we put the red marble back, so we still have 20 total. And how many blue marbles? 6. Okay. Now, guys, there's going to be a couple ways to do this, all right? The typical way without a calculator is you multiply straight across the top. That's the normal way to do it. And then there's ways where you can reduce the fractions before you multiply, because I mean, I don't want to get 400. You know, is there a way I can make that smaller by reducing first? But none of that is really necessary if you have a calculator. So we're assuming you have a calculator and your calculator does fractions. If it's scientific, it does fractions. So really, you can just type in 5 fraction bar 20 times 6 fraction bar 20 equals, and it just gives you the answer. Okay? Just gives you the answer. But I'm just going to go ahead and do the little, you know, sometimes you guys don't have that fraction bar, so just go ahead and do 5 times 6 in your calculator and get 30. And then 20 times 20 is 400. Now, some of your calculators can convert decimals into fractions. So I can do 30 divided by 400. And I'll get 0.075. Well, I don't want that. So there's a button on my scientific calculator, TI-30X. There's a button that converts that to a fraction. And I take care of that, and it says 3/40. Okay? So let's do B. I'm just going to go ahead and do number 1, the whole thing with you guys, and then we can do number 2 in your partners there. So as a turn-in. So blue marble, second blue marble, and then a white marble. So this is with replacement. So this is going to be, blue marble is 5 out of 20. We have so that's blue marble, another blue marble.
Blue marble is 6 out of 20.
I'm sorry, I'm looking at the wrong thing, sorry. Something was wrong here. 6 out of 20, right? And then another blue marble, same ratio, same probability, because we're putting it back. We're putting the first one back, so it's not affected, the second one. And then what about the white marble? Okay, so you see how this can get kind of crazy if you're doing this by hand. All right? So, you know, again, you want to use your calculator. If you have the fraction bar button on here, not necessarily the division. Because if I do division, 6 divided by 20 times 6 divided by 20 times, it's going to give me a decimal. Then I have to convert it. That's fine. Okay? So, anyways, let's just say I just want to, look, I don't have a nice fancy calculator. So I'm just going to do 6 times 6 times 9 is 324. 20 times 20 times 20, that's 20 to the third power. That's 8,000. Okay? And then, so my calculator, if I type in 324 divided by 8,000, with the fraction bar, it's going to reduce it for me. I don't have to think of, you know, greatest common factors and all that stuff. And that's just going to go down to 81 over 2,000. Okay? So this is not going to be very nice without a calculator, guys. It's possible. It's fun, but to me, to you, it may not be. So make sure you learn your calculator. Okay? If you have questions about it, I can come by and help you out. All right. So this time we're going to do the same 2 without replacement. That means once we pull out the first marble, we're not going to put it back. That means there's less marbles, and especially of that color we just assumed that we chose. So the first one is the red marble is still 5 out of 20, but we're not putting it back. So what's the probability of pulling a blue marble? 6 out of 19. One marble less. Okay? 1 marble less. And then, oh, that's it, right? So you see it's slightly different. Slightly different. So 20 times 19. That's the wrong. And then 3 out of 38. All right? Now, we're going to do 1D. 1D has 3 fractions, but without replacement. So the first one's the same, 6 out of 20. But we're picking another blue ball, and we just picked one out. So not only does the total go down by 1, but the blue marbles go down by 1. So instead of having 6 marbles, we're going to have 5 blue marbles. Okay? So 6 blue marbles at the beginning. We took one out. We didn't put it back, so now we have 5 blue marbles, and we have 19 total marbles. All right. And then we're going to go ahead and take a white marble. How many white marbles are there? There's still 9. We didn't take any out.
Over 18?
But there's another ball less. We have 2 less balls there. And now we have that setup. So again, if you have a nice calculator, you just type it all in, you get an answer, and you're done. If not, you're going to have to play with the numbers somehow. Okay? So if you think it's easier for you to just go straight across, that's fine. 6 times 5 is 30. 30 times 9, that's going to be 270. And then 20 times 19 times 18 is 6,840. So that's the right answer. It's just not reduced. Okay? And since it's not the right answer, since it's not reduced, we have to go ahead and use your calculator. That's the quickest way. Hey, calculator, reduce this for me. Great. If not, you have to think of all kinds of numbers there. Okay, what does this come out to?
76.
Yeah. Okay, so what I want you to do with your partners is to go ahead and work on number 2. Okay, work on number 2, and I'll post the solutions a little bit later.
Are we doing these then?
So here's number 3. A cooler contains 4 root beers, 8 Sprites, 3 Cokes, 5 Mountain Dews. If 3 drinks are selected in succession, what is the probability that... Okay, so notice that you're reading, there's 3 events happening. Okay, when we're about to go to the next page, there's only one event, although there's multiple things you're looking at. So notice, if I was taking notes or whatever, I would be like, okay, there's 3 drinks, there's 3 events. That means there's 3 separate calculations I have to come up with, or probabilities. Now, in the book or online, when you're doing your work, you may see it'll be look like this: probability of Sprites times, like, let's say you click on help me solve this or whatever, you might see it like this: Coke, okay, P, and then a Sprite again. And notice that it says with replacement. Okay? So all you have to do is just fill this in. So a probability of Sprites, well, first of all, what's the total? 20. All right? Do we have the same numbers? Yeah, this is just a total soda. So Yeah, I don't know. Most of these are 20s for some reason. Less than 20, 25, 16, stuff like that. Okay, so Sprite, there are 8 Sprites right there. So it's 8 out of 20 times Coke, 3 out of 20, and Sprite again. We still have the same amount of Sprite, so it's with replacement. Okay. So once again, you type this all in, get an answer, or you go straight across the top and get 192 and 8,000, and that reduces to 3 over 125. Okay. So I just want, okay, let's go over the interpretation of this. The probability, remember, we can visualize that fraction by just getting the decimal version. 0.024. So if we do the percentage, it's 2.4%. There's a 2.4% chance of grabbing 3 times from the cooler and actually getting a Sprite first, a Coke second, and a Sprite third. It's a very small chance, 2.4% chance to get those 3 in that particular order. That's the interpretation of what we're doing, okay? It's not just random stuff we're just doing for the fun of it. But this is actual real life, what are the odds? What are your chances, okay? So guys, I want you guys to do in your groups these 2, okay? So the next page is 1 event, not 2, not 3. It's only 1. That makes a big difference. But in this 1 event, there may be varying. So varying characteristics. Oh gosh. So what do I mean by that? Well, if you look down at the pictures, you have the number 2, but you have a 2 that's a circle and a 2 that's a rectangle. So it's going to be a little bit weird. Now, you can have 2 characteristics that are not shared, like that. And I'm being very non-mathematical when I say non-shared. Just trying to say it in a way that not too many technical terms here, because this is called mutually exclusive. There's no overlap. We talked about this before in sets. There's no overlap, mutually exclusive. For example, you cannot be a circle and a rectangle at the same time. There's no overlap of 2 different shapes. But one number could be both, as in this picture, okay? So the calculation here, guys, is just going to be probability of A plus probability of B. Okay, sort of like what we've done in the previous sections. But if there's shared characteristics, so that's gonna have some overlap. This is gonna have some overlap. So the calculation is different. So they share something in common. Okay? So the calculation then is going to be, we add these up, but then we have to subtract the both. So probability of A and B. So that's just both happening at the same time. The both is right here. Okay? We have to subtract that out. Okay? So let's go ahead and do the first couple examples, and I'll have you do 8 and 9. Okay? So, all right. What's the first thing you always do before you start? Total. You got to know how many total. That's the number in the bottom. Thank you. So, total here would be 16 total cards. Okay, if you notice, we have a row of odd here, we have a row of even here, odd here, and even here. Okay, so, all right. So notice, guys, it says one shape. That's one event. You're picking once, that's it. Even though you see multiple things happening here, but it's only one event. Okay? So, what does it mean that you can get an odd number and a rectangle? So, if you remember back, I think it was in the worksheet for. So we're going to look for how many both. So really, we're just trying to find this intersection right there. It's not really adding or subtracting. We're just going to find that both part. Okay. All right. So both odd and rectangle over the total. That's it. Both odd and rectangle over the total. So how many is that? We said 20. Oh, I'm sorry, 16. So how many are both a rectangle and odd? So we can just ignore the circles. Go to the rectangles. How many are odd? 4. Okay. There's odd circles, but it has to be both rectangle and odd. So we're only looking at the rectangles and the odd ones, and that's just 4 over 16. So what's 4 over 16 reduced, guys? 1/4. Okay. Now, the or is different. The or, we're going to have to see, for the or, you need the both, so you can subtract it from both characteristics being added together. Okay? So this one's going to be 3 fractions, add in, and then subtract. Okay, so probability of even plus probability of, so it says or, rectangle minus both. Minus both. So what's the probability of pulling an even card here? We have 4 even right there, 4 even right there. That's 8. Okay. I should be pointing here. So 4 even here and 4 even there. That's 8 even. 8 out of how many? And how many rectangles? 4 and 4. That's another 8. Whoops. And then subtract both. So how many are even and rectangle at the same time? 4. Yep. So what's 8 plus 8? 16. 16 minus 4 is 12. And that reduces to Okay, greatest common factor will be, you can use 4 as the biggest one. 12 divided by 4 is 3, 16 divided by 4 is 4. Or put it in your calculator and not worry about it, right? You can actually just type the whole thing in, plus, minus, press enter, and it gives you the simplified version. Okay? So once you guys try 8 and 9, so let me just do this last one to wrap this up. Number 10, you have pieces of paper with 1 through 10. Put it in a hat, okay? You know, this happens when you're picking whatever, who's going to go first, or who's going to get a prize or whatever. So notice that you see one piece is taken out as one event. The probability of the piece of paper selected contains an even number or a number greater than 6. Okay? So once you see that or, it's the probability of both added together. And then you're going to subtract both. Now, because this is actually listed out, we can actually just look at the numbers and count them if you want to. So, even numbers, we have 2, 4, 6, 8, and 10, right? It's 5 even, 5 odd. So this will be 5 out of 10. Now, how many numbers greater than 6? 4. Can't include 6, so that's going to be 7, 8, 9, 10. That's 4. Now, how many match both at the same time? How many are even and they are greater than 6? So 8 and 10, that's 2, right? So 9 minus 2 is 7. Okay. Okay, guys, this is going to be it for this lesson, for this video, and let me know if you have questions over the break on this stuff when you're working.